Satellite meets you where you are. The client provides the infrastructure. And from that infrastructure, we're able to create what we call satellite locations. You'll see an example of a location on the next slide. We create these satellite locations, and what these locations give us is the ability to then provision our managed cloud services in them. And as we provision those managed cloud services, we're able to provide, IBM is able to provide all the SRE, all the site reliability engineering, all the patch upgrade release lifecycle, excuse me, all the day two operations. We do all the day two ops on those managed services. And satellite locations are secure. They come and they intersect with the financial services cloud controls we're doing, the other compliance and regulatory work that IBM is doing. All right, so let's kind of move forward here. When we talk about a location, a satellite location, it's fundamentally moving a hybrid cloud or a private cloud architecture from something that the customer installs and configures and manages to something that IBM helps you provision and then IBM manages for you. So here's the way a satellite location works. It works from the bottom up here. We start out with client infrastructure. The client can provide infrastructure that could be bare metal machines, they could be virtual machines. They could buy hardware from IBM or one of our partners. Well, we'd be more than happy if that happened. But they can also provide infrastructure from the edge, right? This could be a telco mech. This could be an edge networking center. This could be edge compute devices that are running on everything from an oil rig to a warehousing distribution plant that's, you know, basically shipping trucks and truckloads of merchandise all over the world or all over a country. Or that infrastructure can come from a public cloud. Literally, you could create one of these satellite locations on a set of AWS EC2 virtual machines or Google Cloud VMs or Azure bare metal or virtual machines. So the point is the client gives us infrastructure. There's some requirements to that infrastructure, of course, but they're relatively lightweight. And then from there, we put down what we call the satellite control plane. So I'm working from the bottom up here. We put down the satellite control plane, and the satellite control plane is a small, thin piece of middleware that converts that infrastructure into a managed cloud region. And once it's a managed cloud region, now you can provision our satellite-enabled cloud services. Services like our IBM Cloud databases for Postgres, DB2, Redis, etcd, etc. Our managed OpenShift service, we call it inside IBM, we call it ROCs, Red Hat OpenShift Kubernetes service. But our managed OpenShift service, continuous delivery, Watson data and AI tools, etc. And then once you have these managed services there, now clients, customers, you can write and then provision your own applications. You can install our cloud packs, which are bundles of middleware that have been integrated to work together, available in a single package. You can install our cloud packs into the satellite location. You can grab applications via operators and Helm charts, et cetera, from the Red Hat marketplace, from the IBM software catalog. So tools like Maximo for predictive analytics, Edge Application Manager, et cetera. The operators that are all available in the Red Hat marketplace. You can provision those all into a satellite location. Now, the key here is that once you've created this location, this gives you these 4 capabilities. I actually usually refer to this as 3+1 because I don't like the third one. I have to always explain it a lot more than I'd like to. So the first capability is, and we covered this, right? It's the workloads where you need them. The idea is it's your workloads and your data can stay on-premise or in a single cloud wherever you need it, or on the edge wherever you need it. Day 2 operations are now taken over by IBM. We're doing all the patch upgrade release lifecycle management. You get access to our cloud catalog of managed services and software that you can install. And this part about the two-way tunnel that you control is that there is a connection between your satellite locations and an IBM Cloud region, one of our availability zones. And the reason for that connection is so that we can do the support, right? We're taking over the day 2 operations of that location. Our support engineers need to be able to push changes throughout the day to the various services you're using. The only way to do that is to be able to access the location through a tunnel, what we call satellite link. But you have complete control of satellite link. You define its ingress and egress points that are allowed. By default, a satellite location comes up basically like a VPC, and we'll see that in a minute. Comes up like a VPC. It doesn't have any ingress and egress defined, and you have to define and allow a connection between IBM Cloud and IBM Cloud Master Region and your satellite location itself. So really that location does actually function just like a mini IBM Cloud region. And in fact, there's really no difference between a location running in my basement or on my on-prem data center and an IBM Cloud region in Frankfurt or London or Dallas or Washington, D.C. From the perspective of IBM, they really look the same. You start in IBM Cloud, you control the location, you basically create the location from your IBM Cloud console or the CLI. And this gives you the flexibility now to place your apps wherever they're needed. And you have a choice of the infrastructure that's running here, right? You can pick the compute size, the network size, et cetera. You have full auditing capabilities on everything that's running. You can see all the packet transfers back and forth. You completely can turn a region up, turn a location up, shut it down, et cetera. I mean, it's yours. And as I said, IBM has taken over the day two ops. We're giving you effectively not a new UI. And that's the key difference between satellite and previous private cloud attempts. There's not a separate user interface for satellite. You don't go on-prem and log into it. Satellite is a cloud region. So in your same IBM Cloud dashboards, you use your same IBM Cloud observability tools for logging, for monitoring, for alerting, for eventing. And you see your regions, your IBM Cloud regions, if you're an IBM Cloud customer, but if not, that's fine. You see your satellite locations as well in the same user interface, the same CLI. You get an auditable inventory of all of your workloads and where they're running. And you get the ability to do basic continuous delivery and configuration management. You get a rule-based approach to do continuous delivery and rule-based management to push resources and workloads onto your satellite location. Now, you can augment this rule-based delivery with additional tools. If you're focused on an edge on an edge appliance, let's say you are running a satellite location in an oil refinery. You have lots of PLCs, programming, logic controllers, SCADA systems, other devices there. IBM has technology called Edge Application Manager that would allow you to push changes, whether they be containerized or binary changes, down to those smaller devices. Likewise, our friends at Red Hat, on the Red Hat side, IBM have their Advanced Cluster Manager tool, ACM, that provides a policy management framework and workload engine that sits on top of the basic continuous deployment and configuration management technology. So out of the box, we give you this rule-based approach, but you're also, more than capable of augmenting that with continuous integration tools, whether you use Jenkins or Tecton or whatever, and then various continuous deployment tools. Now, when it comes to security, as we said, that satellite location is completely closed off. It has no ingress and egress that's allowed to it, and you define the security posture, right? So we automatically create that location. You have to immediately agree to open up the holes where IBM support will be able to remotely get in and push changes. This runs on top of your secure transport, and we'll see an example here and create an endpoint. But this runs on top of your secure transport, whether that be something like Direct Link or just HTTPS, secure gateway, etc. Data is encrypted at rest and in transit. And you have full auditing, you have full governance. You can turn this tunnel, this link on and off as you need to. And really the key here is that the satellite location itself is effectively a mini IBM Cloud region. There's no difference between the location and a satellite location and an IBM Cloud region, running in one of our availability zones. So you have full access to the IBM Cloud services, our IBM Cloud software, et cetera, right through our main IBM Cloud catalog. Now, I'll tell you that satellite's a new offering. We just went GA in March, beginning of March. So much like when you roll out a new region, a new availability zone, not all your services are available overnight there. So we have about 120 PaaS services, platform as a service, PaaS services in the IBM Cloud catalog. Right now, there's only a handful of services that are available to run in satellite locations. But then every month, as we kind of go through the rest of the calendar this year, we're adding other IBM Cloud regions to act as the master region. We're also adding other IBM Cloud services. So the goal is to bring the bulk of the catalog, the essential set of cloud native services for databases, eventing, OpenShift as the Kubernetes source for containerization, all of our Watson data and AI, Cloud Pak for data as a service capabilities. We want to bring all of that in addition to our legacy middleware through Cloud Pak for integration. We want to bring all of that and enable that to be able to run on a satellite location. Today, as in right now, in March 25th, when we're doing this first session, it's mainly ROCs, our managed OpenShift service. It's all of our Cloud Paks can be installed and provisioned into that. And it's our continuous delivery pipelining tools based on Jenkins and Tecton. And it's Cloud Pak for data as a service that's available. And then we will be adding more and more services on top of that. So at this point, I want to end the slideware and kind of get to showing you satellite. But I do encourage anybody to go to ibm.com/cloud/satellite. That is our main marketing page where you can get some information about satellite. We've got some of our YouTube videos posted, etc. On that. And then from there, you'll have a link, obviously, to IBM Cloud itself, where you can learn more about satellite. I don't expect anybody to write down my name right now, but you are more than welcome to reach out to me after this, watching a recording, what have you, at IBM. And I'd be happy to talk to you, connect you up with an IBM team, or just talk about your situation and see if it's a particularly good fit for what we're doing. All right, so let's kind of transition then into some more real world stuff, and let's look at satellite itself. There we go. All right, so I've already logged into IBM Cloud, and what we see in IBM Cloud is your traditional dashboard. If you're not familiar with IBM Cloud, this is our dashboard that you come in to IBM Cloud from, and what you have is a picture of all the devices and the clusters, et cetera, that you have. What you'll see here is I have a number of satellite locations that are created. I've got a couple of disks that died last night on me, and I wasn't able to replace this morning because of some other activities. So we've got some warnings that we can look at, et cetera, and I've got some databases running, et cetera, et cetera. So, from IBM Cloud, you can access the catalog, or you can take kind of the shortcut and look at our menu here, which is our global navigation. So what I'm going to do first is I'm just going to go to satellite itself. And this is our satellite landing page inside IBM Cloud. It has, what the things are that you would consider as a typical landing page, right? It's going to give you a little bit of background. You're welcome to join our Slack group. And then it tries to give you some very quick getting started material around how would you create a satellite location? What are the steps in order to do things? Sai will take you through a video on what satellite is and how easy it is to get set up. And then you can kind of click over and get over to our docs. And I want to highlight our docs because it's interesting that we've been able to put a lot of effort into our documentation and really try to simplify what is a pretty complicated task. Standing up a cloud region on generic hardware. Whatever the client gives us, we want to be able to stand up a region. So this has lots and lots of tutorials about security, about your responsibilities versus IBM's responsibilities, how to set up satellite in a VPC environment, how to set up satellite on AWS, Azure, GCP, closed networking environments, open networking environments, et cetera. We've got a video here from Jay Kitchener, who's our lead architect for satellite. And we did some work with Intel where Intel donated some Intel NUCs, some great little boxes. And we were able to stand up a satellite location on a couple of boxes to use in various edge scenarios that we'll take you through. So our doc set is pretty complete with respect to, step by step by step. How do you create a satellite location? How do I get more information? How do I secure it? What's the architecture underneath satellite itself so that you're comfortable with understanding how to do things? Now, the good news is, what do we mostly do? We log into a service, we don't read the documentation, and then we click create. And that's perfectly fine too. So when you click create, as I said, we've only been around for a couple of weeks now. So we give you three options. You can create a satellite location on AWS. You can do it manually, or you can use something called satellite infrastructure services. Satellite infrastructure services is a hardware option where IBM provides you effectively a lease and OpEx model on hardware. So you basically get a set of hardware that's installed and configured, and then boom, it comes up as a satellite location for you. IBM charges you monthly based on what you consume. So it's an OpEx model. But otherwise, you can run satellite. You can run satellite in Azure, or GCP, or Oracle, or Alibaba. We just have a tile right now for AWS. Over the next month, we'll add plenty of tiles here for other hyperscalers, other public clouds. But right now, we'll step through the steps that require, you're going to do it manually. So manually, you click manual setup. You give your satellite location a name. You can give it a tag. You can give it one or more tags if you'd like. The resource group in IBM Cloud that you want things to be associated with, and then you have to assign it to a region. Every satellite location, no matter where it's running, has a tether back, that link back to an IBM Cloud region. Now, right now, a couple weeks into GA, we only support London and Washington, D.C. Frankfurt's coming on board. Dallas is coming on board, followed by the other regions throughout the year. Basically, every month, we're releasing a new region. But it's a pretty easy form you fill out, and then you're going to click Create. Once you click Create, what's happening is we're provisioning the part of the control plane inside of IBM Cloud itself. And we're setting up basically a database entry and the management pieces that are necessary for your account, where now you can start to actually make that location real. And this process, this creation process, takes a bit of time. We're not going to sit and wait for it. This demo is going to be very much like a cooking show where I'm going to have to skip to some stuff that's been pre-created as we walk through and go through stuff. So what happens is you create your location, the creation's in progress, and now it starts to walk you through this wizard that takes you step by step around what you need to do to get your location actually up and running. So if you remember, I'm just going to click next. If you remember, what we said was satellite locations run on your infrastructure. So you need to give us some infrastructure. So you can imagine having some bare metal machines or some virtual machines that are going to be your infrastructure, and you need to have those VMs and those bare metal machines register themselves with the location. And the way they do that is you download this script. We call it our attach host script. Every time you create a location, you get a unique attach host script. What you're going to do is you're just going to grab that, you're going to download it, and then that script, that shell script, needs to be run on each of the infrastructure pieces you have. Now, if you're using something like Terraform for provisioning your infrastructure, whether it be VMware or Google Cloud or Azure or on-prem, doesn't matter. You could use Terraform and Ansible and then add this script as part of your Terraform and Ansible workspace. And in doing that, as you create the infrastructure now, automatically, it'll end up registering itself with the IBM Cloud Satellite region itself. Once you've done that, once you've downloaded the script and you've executed it on your infrastructure, what you then need to do is you need to assign some hosts. And you'll have a list of hosts that are available, and then you'll click the Assign Hosts button, and you'll assign the host itself. And then at that point, those hosts now are registered with the location. The control plane has been placed. That's that thin layer that we talked about before. The control plane's been placed now on that location, and now that location is a fully vetted, running mini IBM Cloud region. So let's look at some of the locations that we currently have. I've got a location here called Pit Loc A. As I said, some of those locations have some dying disk drives from other places that I provisioned. And I have locations right now running in Google Cloud. I have a couple running on some non-IBM Cloud infrastructure that I have on some third-party VM, Cloud VM providers. And I have some locations right now that are actually running in an IBM data center that's actually not part of IBM Cloud. But when I have a location up and running, this is kind of the screen that I see, right? I see the satellite location screen, and what I can look at is I can look at my locations, my hosts, and my services that are running on them. What I see here is that I have 15 hosts, and 3 of them haven't been assigned to do anything, and 12 of them have been assigned to work. So let's look at our hosts list. And I think, let me sort this. Okay. So what I have is I have a set of hosts. These are all VMs. None of these are bare metal. So I have a set of hosts. All of these hosts, just because I was lazy, have exactly the same configuration. They're 4 virtual CPUs and 16 gig of RAM. I was able to use some Terraform scripts to just generate these automatically. And what you'll see is I actually expect to build this out to quite a bit of stuff. So I have a control plane here that has 6 of these hosts are dedicated to the control plane. That's an awful lot, but it was just an example. I was doing a prior demo of this. Typically, you'd only need 3 hosts for the control plane. So, and I also have 2 clusters here. I have a cluster for dev that has 3 hosts associated with it, and I have a cluster for production that has 3 hosts associated with it. And what I could do is, if this were empty, if I had nothing assigned, the process is I would go to that screen that said assign host, or I could do it right here. And what I would get is I would get a list of things I could assign that host to, right? It could be an existing Kubernetes. These are all Kubernetes clusters. It could be an existing OpenShift Kubernetes cluster that I have, or I could assign a host to the control plane. And then, because this is an HA configuration, it's set up for high availability, I have three zones that are running. Now, in an ideal world, those zones are all physically separate servers. Zone 1, Zone 2, Zone 3 would be physically separate servers. I'll admit that here I just went out and created a bunch of VMs. I have no idea if these are running on the same server or separate servers. Not a production scenario, obviously. But the point here is that I could grab a zone. I could say assign this host to the control plane, and then I'm going to click on assign host. You might see a cost at the bottom. The point of the costing is that Satellite, from a pricing perspective, only charges you for what's being used, like what we're managing. So if you provision some databases and some Kubernetes clusters, some OpenShift clusters, et cetera, that's, whatever you're using for that, that's what the charging is based on per hour. These unassigned clusters, on the other hand, they're registered. Now we're provisioning this one onto the control plane. They're registered, but you're not charged for that. So it's a pretty common scenario where you would register, let's say, 1,000 virtual CPUs of capacity, but maybe you're only using 100 and then 200 and then 500. Well, if you're using 500 and you've provisioned or assigned 1,000, you're only charged for that 500. That's the idea. All right, so we went through how to create a location. Then once you have locations, you register the hosts. From the host, you then can manually assign them to the control plane. By the way, there is an easy button. There's a switch you can set up where we do auto assignment for you. But this is kind of taking you through the step-by-step approach. If you want to see what's actually running on that location, you can click on the services item. And what you're seeing here is I've got 2 OpenShift clusters and the satellite control plane running. I have 7 hosts on the satellite control plane, and I have 2 OpenShift clusters. Each one has 3 hosts running on them. And then I can start to look at the link endpoints, and I can start to audit that traffic as well. So if I click on link endpoints, this is the connection that goes back from the satellite location to anything else that you have. And I really mean it's anything else. So let's say you're running in a data center, you want to connect to a mainframe that's the system of record in the data center. Well, you have to create a link endpoint for it. Let's say you want to connect back to IBM Cloud so that IBM Cloud can do the support on the location itself and all the services. Again, you need to create endpoints for those. Now, by default, we create many of these endpoints for you, but you can turn them on and you can turn them off, literally with a click of the button. You can expand an endpoint, and what you see in the endpoint is the details associated with that. Each endpoint has a physical, a physical address and a port associated with it. And every time you want to access and allow ingress or egress, this is what you do. You define an endpoint, and from that endpoint, you allow permissions. So for instance, what I have here is I have an endpoint that goes to our IAM environment, or identity and access management. So this satellite location will use IBM IAM to do authentication. I have an endpoint that connects back to our cloud object storage bucket. So all of your data is encrypted and backed up to cloud object storage, all your configuration settings, et cetera. is backed up to Cloud Object Storage by default here. And I also have endpoints created for sysdig and logDNA. These are our observability tools for logging and monitoring, et cetera. And I'll show you these in a second. And then likewise, you can click on audit. I've only been running this location for a while. And once you audit, what you can start to do is, as you start to use a location, you can start to audit the traffic across all of the endpoints here. All right, so let's look at another location here that we're creating. Oh, this one's fully up. I probably should have shown one that had a little bit of a disk problem. Oh no, this one looks pretty good. Okay, so when we open up, what we'll see is a set of hosts, just like we had before. We kind of go to our services view for locations. And what we'll see is we have a satellite control plane and we have a couple of clusters that are running here. All right. So what if you have a location that doesn't have much on it, doesn't have anything on it? Well, again, this is just like IBM Cloud, right? There's nothing unique here about a location. A location works just like an IBM Cloud region. So what I can do is I can go to IBM Cloud and I can start to search through capabilities. I can sort based on satellite. I can do a query for data and AI tools, what have you. Or I'm just going to take the easy button out of this and go back to the beginning. Oh, I missed that. Sorry. I'll do it through global navigation. I'll go to OpenShift. I'll go to my clusters view. And what I'll have here is a list of all of my clusters that are currently running. And what I'll do is then I'll provision a cluster, and we'll see that it's exactly the same process that is accessible via regular IBM Cloud. Let's see what's going on here. There we go. That's better. So I'm going to provision an OpenShift cluster. I can select the version of OpenShift that I want. And normally in IBM Cloud, I would say I want to run this on either classic infrastructure or a virtual private cloud. But I don't have any VPCs created in this resource group. But what I can do is I can create a cluster on satellite. So the difference here is when I select something like classic, I get the various IBM Cloud regions. I can select a multi-zone or a single zone approach, and then I get the location that I want to use, whether it be in Asia Pacific, whether it be in Europe, what have you. And these are all the IBM Cloud regions. Well, if I want to create that same managed OpenShift cluster, I now just say, well, create that using satellite infrastructure. And what I get now is I get a picture of here are the locations that I have. What's the state of them? And if I want to provision, this one only has 2 nodes available. Here, this one's good. It's got plenty of space. So I can pick pit loc B. I can say how many worker pools do I want? Do I want it across 3 zones, 1 zone, 2 zones? What's the size of the machine that I want? And I will get an error if I pick, I want a 128 virtual CPUs, and the only thing that's available is a bunch of 4s. So I would get an error from the system to that. But the point is, this is the exact same interface. Then I have this choice of turning on satellite config. We'll cover that in a second. And I can give my cluster a name, and I click create. So this is exactly the same IBM Cloud interface for provisioning managed services, for provisioning OpenShift clusters, etc. But now I'm doing everything onto a satellite location itself, as opposed to on an IBM Cloud region. So for instance, we can go and look at this cluster, Dev02 SL Demo 01, catchy name, I realize. So this cluster is running. It's actually got 3 nodes. It's in good shape. If you look at the warning that's available is that I have a disk failure that's happening on one of the nodes. So it keeps shutting the node down and bringing it back up. I'm going to open up my OpenShift web console from here. And if I open up my console, this is the regular OpenShift web console. It's the same system again that would be available if this was running in Washington, D.C. or Dallas or Frankfurt. It just happens to be located in, I think these virtual machines are located somewhere in the South in the United States, like Georgia or something like that. But here, what you can see is you have the OpenShift web console with all the various projects that are available, details on the clusters, All of the traditional cluster utilization metrics are captured, and a quick view of our activities and all the errors that are associated, all the successful activities that are associated with that. I was running some batch jobs on here that if we scroll through, we should see some errors on, because I had the batch jobs listed wrong. And then I can get a list of my projects, and I think I have only about five basic projects plus the regular OpenShift stuff. But we'll look at this Express Simple project here. Oh, I need to switch over to the developer view. So if I switch over to the developer view, I see that I have this node server that's running Node.js. It's a single pod. It's running on port 3000. I can access all the YAMLs, etc. And then I can just, run this simple service. Here's my URL endpoint to run this simple service that just says hello world. The point here is that this is very underwhelming. But think about it. I created a cloud service from a collection of infrastructure that I owned, or some infrastructure that was running in Google Cloud or AWS or GCP. And I provisioned it just like I would provision anything else in IBM Cloud. So then I have access to all the tools like the OpenShift web console, like the cloud dashboards, like the Postgres dashboards, etc. Same thing with Cloud Pak for data, for the Watson data and AI tools. It's treating this location just as if it were a region. It's actually a kind of a mini IBM Cloud region. So the same tools, the same observability that I use to access anything else in IBM Cloud, I now use to access the satellite location itself. So if I go over to the IBM Cloud section on observability, this is where I see activities and logs and monitors. And click on logging, and this should bring up, I think I cleaned this out last night. I only have one platform logging set up now for Washington. And let's go and look at its dashboard. And what we see here is I have everything turned on. It's not being filtered. But we'll see all of the various alerts and events that have been happening across my satellite locations. It looks like I have some IBM Cloud databases running in that satellite location as well. etc. And you can, this is our regular log DNA environment. So I can start to open up and explode the JSON associated with every logging entry here. I have full access to my search. All of my logs and my monitoring data, if I enable it, are shipped from that location and streamed back up to my IBM Cloud account. Now I can turn that off if I want. If I'm concerned about PI data, security, etc. But by default, all that information comes back up, and now I can search it, I can sort through it, etc. Likewise, I can go back and I can look at my monitors of my Kubernetes clusters, etc. So instead of bringing up each individual OpenShift console or each individual database console, I can bring up, I can bring up Sysdig, and I can start to look at a summary of what's available in those dashboards. So for instance, I should be able to go and look at, this is a collection of the satellite link data across the locations that we created. So for instance, now I can start to drill down and I can start to look at, where was satellite link data between the OpenShift API and the health checking data happened? At what time did that happen? I can start to drill down into this and really start to get really detailed monitoring data for my satellite locations and my Kubernetes clusters. So I should be able to go and let's see, where are we? I should be able to go and look at my container. Oh, I may not have my my clusters turned on. Let's see what we have. Yep, I don't have my clusters turned on. So I don't have my my observability data turned on for my clusters. But all of the information that I have turned on is available then in my monitoring, in my alerting, and in my availability. All right, last thing I want to talk about with satellite here is what we were talking about with this notion of satellite config. So inside of satellite in this overview, we talked about locations, we talked about link, which establishes a connection, all your ingress and egress between IBM Cloud, the location, or anything else, a third-party service, etc. We also give you some additional tools that do cluster management. And these come in satellite. If you have an IBM Cloud account, you can access this even without a location. And the idea here, the idea here is that a satellite location has compute workload running on it, and we want to give you some base tools for configuration management and cluster management. So what you have here in this location is the set of clusters. So in this location, you have the set of clusters that are running. And what you can start to do is you can start to create cluster groups. So I created a group called CG Demo 1. And CG Demo 1 has two clusters in it. It has this SL Demo 1 cluster and the Dev Pit Location B cluster itself. And I can just add clusters from the list. I can just pull down a list and I can add clusters into a group. But the key here is subscriptions. This was the error that I had the other day or this morning when I was getting this all set up. I need to fix my my Kubernetes YAML. But the point here is that I can create a subscription. So the subscription is associated with that configuration. And what happens now is as I create changes in my subscription details, so this is my Kubernetes YAML. You could have one YAML, two YAMLs, doesn't matter. As I create changes in this case, it's versions. Once I go from version 1 to version 2, this will automatically push changes to all the subscribed clusters. So the idea here is that this is my basic continuous deployment tool. As I make changes to my Kubernetes environment, as I upgrade my images, as I make changes to my resource groups, to my services, etc., what I now have is an ability to push those changes to all the clusters that want them so that I can keep things in sync, regardless of what locations they're running on, right? Regardless of whether they're running in location A, location B, in dev or prod, etc. So I can use this notion of satellite config to push changes from dev to prod to make sure all the development locations have the same set of workloads running on them with the same underlying versions of middleware, etc. So it's a basic tool to allow you to do config management and cluster management. Red Hat makes a much larger, fuller featured capability called Advanced Cluster Manager for edge applications and edge devices. We have the Edge Application Manager technology that fundamentally is very, very similar, but it's not. Those are optimized for different kinds of devices and a larger level of deployment. This SAT config technology is in the box. It's what we actually use at a low level for all of our, I think now it's tens of thousands of clusters that we manage internal to IBM, and then our client clusters are even managed using these as well. All right, so we're at about 50 minutes in. What I'd like to do is thank everybody for coming. Again, my name is Dave Tropeano. I'm the program director for IBM Cloud Satellite. I encourage you to learn more about Satellite by going to ibm.com/cloud/satellite. It's very easy to create a location. It takes about 30, 40 minutes to create a location. Then provisioning a Kubernetes environment, database, et cetera, is going to take some time on top of that as well. But by and large, once you've done that, you now have a mini IBM Cloud region that you can use, whether it be on-prem, on the edge, or in third-party cloud. And that's really what Satellite is all about. All right, so there was a question here that I'm happy to answer from Neil, and asked, is there a differentiation based on CPU architectures? For instance, can I run a satellite location on ARM or can I run it on x86? That's a great question. Right now, satellite is x86 only. So all the satellite locations are fundamentally running on x86 hardware. And as we progress over time this year and next year, we're considering allowing locations to run on Power hardware, likewise running on Z. We're looking at ARM and other architectures as well downstream. I don't see any other questions that came in. So at this point, I'm going to leave the session. Again, I would like to thank everybody for attending. Feel free to reach out to me if you need to go to ibm.com/cloud/satellite